Okay, all right. And today we will be transforming a Cartesian coordinate Lagrangian into a polar coordinate Lagrangian. So let's get into the ideas first, and we will derive that one by one. So in general, the Lagrangian is given as L is equal to T minus B, and T is the kinetic energy in Cartesian coordinate, which is given as of mv square. So I can write it as of m x dot square plus y dot square plus z dot square. So once we have a Cartesian form, right? So x dot square plus y dot square plus z dot square, and v is the potential, which is a function of x, y, and z, right? So this is the Cartesian. So then this to the polar coordinates, right? So we know the transformations. That is, for the in order to transform a Cartesian set of coordinates into polar coordinates, we know x is equal to r cos theta and y is equal to r sin theta, and z will preserved as it is. Right? So z is this it, and this is for once you include this z and this is given under cylindrical. The polar coordinates only inputs x and y. Right? For the time being, we have to stick with this x and y. That's it. Okay. Once you include z here, then we are getting into the polar coordinates. So now we are going from Cartesian to polar coordinates. So once we have x, and in this equation we have x dot y dot, right? So we don't have z. We don't want to bother about z at while transforming from Cartesian to polar. Right? So the x dot, we have two terms, just r and theta. So we can write r dot cos theta. First we have to differentiate r, then we have to differentiate theta. So r theta dot sin theta. Similarly for y dot equal to r dot sin theta plus r theta dot cos theta, right? So then we have t is equal to of m x dot square plus y dot square, right? So first let's find x dot square plus y dot square, right? So we have this term in this equation, right? So what is x dot square and y dot square? So we have x dot and we have to square that. So we have to square this term, right? We have to square this. So we can write r dot square cos theta square cos square theta plus r theta dot sin square theta minus 2 r r dot theta dot, and we have cos theta and sin theta. This is for x dot, and we have y dot square, and we have to square this, right? So we have r dot square sin square theta plus, we have to square this also, so r square theta dot square, so plus r square theta dot square cos square theta minus 2r theta theta dot cos theta and sin theta. Right. So once you take r dot square commonly, you can find cos theta plus sin square theta. So we have r dot square, which is sin square theta plus cos square theta, and plus we have r square theta dot square, and we have this sine square theta plus cos square theta, and you can find this is there's a plus here. I wrote mistakenly this is minus, and this is will be written as plus because we have a plus b whole square here, so we can cancel these two terms. So we will end up with r square r dot square. This will become 1. Sine square theta plus cos square theta equal to 1. This is 1, and this term also becomes 1. So r dot square plus r square theta dot square, so which is the t term, and we have additional constants here. So we have t equal to 1 by 2 m r dot square plus r square theta dot square. So this is the Lagrangian, sorry, this is the kinetic energy term for in polar coordinates, and the potential energy must be the function of potential energies be the function of r and theta. Okay, provided you have to clear that the potential energy consists of only r and theta. We should not have any other terms in that potential energy. Once we have any other term, then we have to switch into cylindrical equivalence, right? So we will look into that later. For the time being, we discussed the Cartesian to polar coordinate transformation, right? So we ended up with the Lagrangian, which is L is equal to of m r dot square plus r square theta dot square minus we have v, which is a function of r and theta. Right? So hope you enjoyed this, and this will be useful for you. So these are the basics. Okay, once you get into these basics clearly, you are able to solve many problems easily. In next video, we discuss how to transform from Cartesian to cylindrical polar coordinates. Right. Okay, thank you for watching the video.